Hello, hi everyone. Welcome to the next video of the series. In this video, I'm going to take some questions of alcohols, phenols, and ethers. Also, I'm getting requests, ma'am, please do GOC isomerism. Please do GOC isomerism. So, students, I am doing GOC and isomerism questions in every chapter of organic chemistry. I have already discussed so many questions in hydrocarbons and haloalkanes, haloarenes. Even I'm going to take some questions in alcohol, phenols, and ethers. If you need more information, then I'm going to make separate video on GOC and isomerism as soon as possible, right? But please, if you do these questions also, na, you can get better knowledge about organic chemistry, right? So let's start the class. Let's start the video in a systematic manner. So alcohol, phenols, and ethers, right? So what we are going to discuss over here, we are going to discuss with the weightage, then we will move to the syllabus, and syllabus I am going to discuss with the help of mind map, and then we will solve some previous year questions, important previous year questions. Next, who will benefit from this video? Who knows the basic? NCRT reaction should be clear, right? But they don't know how to solve the question. They have NCRT level knowledge and has taken coaching somewhere so that they have all the notes with them, right? They have all the reactions because there are so many reactions which are not in the NCRT also. So it means you have to revise your coaching notes very well, right? You have to understand the concept of GOC reaction mechanism very well. Okay. Now, how to use this video? You have to revise the short notes. So I have been telling you from the starting how to revise the short notes is just in the organic chemistry, you have to write down all the chemical reaction in one go, right? So you should be having all the chemical reaction, and with respect to all chemical reaction, you should know key in this reaction whether SN1 happens, E1 happens, E2 happens, or which type of reaction mechanism we are going to follow in that particular kind of reaction. So you should have all that kind of information. You should write down those information and then you can start doing the practice. Now, if we talk about the weightage, so weightage is around 4%, or we can say one question is going to come, right, in your exam. Now, let's discuss mind map. So in organic chemistry, we know that here we have alcohol, right, phenols, phenols, and ethers. Okay. So, beta, we have to discuss physical properties. We should know physical properties, right? Physical properties of alcohols, phenols, ether. We should know chemical properties. It means you should have the idea about all chemical reactions of alcohols, phenols, and ethers. And then uses, right? Uses, classification, right? Classification of alcohols, phenols, and ether. So that part you should know. But major part is physical properties, chemical properties, and uses. One more thing, preparation. One more thing, preparation. Preparation of alcohols, phenols, and ethers. It should be clear. You should have all the chemical reactions with you. Okay, now moving on that part, let's discuss type 1 questions. And in the type 1 questions, I'm going to take some questions related to GOC and reaction mechanism. Okay, so now moving on to the question number 1. So question number 1 says the increasing order of pKa for the following phenols is. So if we talk about the phenol, phenol is this OH. Okay, phenol is OH. So here hydrogen is bonded to more electronegative atom. More electronegative atom. So it means electronegativity difference of OH bond is high. Is high. So we can easily remove this hydrogen, and when we remove hydrogen, we get phenoxide ion. We get phenoxide ion. Phenoxide ion. Phenoxide ion, which is resonance stabilized. It is resonance stabilized. It is resonance stabilized. If we see how to draw resonance, so this is going to be the first step of the resonance. This is going to be the first step of the resonance, right? So this is resonance stabilized. So we have conjugate base. Conjugate base. It means negative charge is there. So whenever we have negative charge, so we have more electron-electron repulsion, and if we have more electron-electron repulsion, so which stabilize electron-electron repulsion? It means if we have electron withdrawing group, so electron withdrawing group stabilize conjugate base. Stabilize conjugate base, right? And electron releasing group destabilize conjugate base. Now again, how to find out which one is electron withdrawing group? So electron withdrawing group, that is going to be like this. Up here X is not halogen. Here you can take A double bond B, A triple bond B, right? So if you see these type of groups attached to benzene ring or any other system, then they are going to be electron withdrawing group. And for electron releasing group, lone pair should be present, and negative charge should be present. Okay, so it means we can say that acidic strength is directly proportional to the stability of conjugate base, which is directly proportional to the electron withdrawing groups and inversely proportional to electron releasing group. Understood? Okay, now we have to apply this concept only. So see, we have pK value we have to find out. Acha, acidic strength is directly proportional to Ka and inversely proportional to pK. Why? What is pK? pK is equal to minus log of Ka. Okay, so first we have to find out Ka. First we have to find out acidic strength. So first is 2,4-dinitrophenol. 2,4. It means this is one position. 2,4-dinitrophenol. This is first one. Second, 4-nitrophenol. 4-nitrophenol. Okay. Third, 2,4,5-trimethylphenol. 2,4,5-trimethylphenol. Fourth is phenol. And fifth is 3-chlorophenol. 3-chlorophenol. So beta, NO2 group is electron withdrawing group. See, N double bond O. So we can compare NO2 group with this one, X double bond Y. So this is electron withdrawing group. It withdraws electron. So in the first case, we have two electron withdrawing groups or two groups which shows minus M effect. It takes the electron from the system. Here we have one electron withdrawing group. Here no group. In the fourth one, no group. Here Cl में inductive effect dominates, यानी it pulls electron. So this is also electron withdrawing group, but here it shows minus I, inductive effect, while NO2 shows minus M effect. If we talk about this CH3, and CH3, these are electron releasing group. So they are in the conjugation with double bond. So here we have plus H effect. ठीक है, plus H effect. So the point is that if we talk about Ka, so more acidic is going to be option number 1 because 2 electron withdrawing group, right? Then we have 2. Why? Because 1 electron withdrawing group. Then we have 5th electron withdrawing group is there, but inductive effect is there. Inductive means temporary shift of electron. What is inductive effect? Ki suppose this is more electronegative atom, I am writing fluorine over here, and this is more electronegative atom. So the shared pair of electrons are more closer to fluorine side. So that's the inductive effect. But in mesomeric or hypoconjugation, complete transfer of electron happens. Okay, minus I. Electron releasing group destabilize the conjugate base, so acidic strength decreases. So after 5 number we have 4th number, and after that we have 3rd number. So what is the pK? Increasing order of pK. So 1 less than 2 less than 5 less than 4 less than 3. So this is least. Matlab first number is going to have least pK. Least pK means more acidic strength. Clear? So answer is going to be this. Okay. Now moving on to the next question. Decreasing order of dehydration of the following alcohols is. So dehydration. So first of all, dehydration occurs in presence of dehydrating agent, right? In presence of dehydrating reagents. And for alcohol, dehydrating reagent is going to be concentrated H2SO4 and heat. or we can say concentrated H3PO4 and heat. ठीक है, so generally these are going to be the dehydrating reagents for alcohol. So now we have to find out decreasing order of dehydration. So what happens in the dehydration? What happens in the dehydration? If we talk about B option, so B option is this, and we have OH. So we have H plus and HSO4 minus. So in the first step, oxygen takes H plus, oxygen lone pair takes H plus and HSO4 minus leaves. So we get OH2 positive. Right. Up now what happens? What happens? If we remove water, so we have carbocation, right? We have carbocation formation over here, and here we can say this is stabilized. This is stabilized one. Why? Because we have the resonance over here, right? We have the resonance over here. Up now what happens? Here we have beta hydrogen. So HSO4 minus, it takes this beta hydrogen, and electron of this bond shifts over here. So we get benzene ring. Understood? When it becomes benzene ring, it is going to be aromatic. And what is the order of stabilizing effects? So first we have aromatic, then we have mesomeric, okay, or resonance, then we have hyperconjugation, and last we have inductive effect. Understood? Last we have inductive effect. So the question says decreasing order of dehydration of the following one. So B may it is going to be fast. B, then D. Why? Because this is resonance stabilized, है ना? We can say resonance stabilized. ठीक है? And then we have C and then A, right? So B, D, C and A. So answer is going to be option number 2. Because if we dehydrate D, so we get this one. Here we have resonance, so resonance stabilized. If we dehydrate C1, so C is this, so we get yeah, this one. This is also resonance stabilized. This is also what? Resonance stabilized. Now A में OH है, right? तो OH में dehydration is, मतलब phenol में dehydration is very difficult, right? Because we cannot have another bond. Benzene is aromatic itself. Clear? So answer is going to be B, D, C, A. ठीक है? So option 2 is going to be the correct answer. Clear? Now moving on to the next question. In the following reaction B is, so H2O positive है, OH. So it means that is H2O in the presence of H plus, right? H2O in the presence of H plus. So what we are going to do? We are going to do dehydration. So let's do first step. So in the first step what happens? We have H plus. So oxygen lone pair takes H plus. These curved arrow movement is going to be from more electron density to less electron density. So oxygen we have lone pair, so more electron density. H plus does not have electrons, so less electron density. So we get this one. OH2 positive and this. Now in the next step what happens? Water leaves, right? Water leaves. So if we remove water, so we write this. We have the formation of carbocation over here. So this is 2 degree carbocation, right? This is 2 degree carbocation. ठीक है? अच्छा, अब now here two things can happen. See, if we have carbocation over here, so if we form bond like this, So we have the formation of 1, 2, 3, 4, 5, 5-membered ring, 5-membered ring. But if we do methyl shift, if we do this shift, here we have methyl group. So if we do methyl shift, we get 6-membered ring, and we know that 6-membered ring is more stable than 5-membered ring. So first we are going to do methyl shift over here. So let's do methyl shift. So on doing methyl shift, we have 1, 2, 3, 1, 2, 3. Okay. So we have carbocation over here. Okay, and here we get methyl group. Clear? Now what we are going to do? We are going to form bond. We are going to form ring. So here we can say ring formation. We will do ring formation. So let's do ring formation. So electron of this bond shifts over here. So we have negative charge over here, and new positive charge will generate over here on this carbon. New positive charge will be on this carbon. So let's form bond. So now 1, 2, 3, 4, 5, 6. Clear? 1, 2, 3, 4, 5, 6. So let's form 6-membered ring. So we get positive charge over here on this carbon, positive charge. This is 1-number carbon. On 2-number carbon, we have 2 methyl group. This is 2-number carbon. Then 3. On 3-number carbon, we have 1 methyl group. Okay. Now next row. Minus H plus. So here we have hydrogen. Okay. So whatever the base we have, it takes this hydrogen. It takes this hydrogen. Okay. It takes this hydrogen. Electron of this bond shifts over here. So we have this. ठीक है, माइनस एच प्लस होना ही होना है, इट इज गोइंग टू हैपन if we have carbocation. So carbocation should be stabilized. ठीक है, so in dehydration we are going to form alkene. Now let's match the answer. So when we match the answer, so option number 3 is going to be the correct answer. Clear? Okay, now moving on to the next question. This question says, in the above reaction, left hand side and right hand side rings are named as A and B respectively. They undergo ring expansion. So the correct statement for this process is, so see H plus, we have OH, we have H plus and heat. It means we have to remove water, dehydration, we have to do dehydration. And after dehydration, the product is going to be alkene, right? The product is going to be alkene. So let's do one by one. So this is 4-membered ring, and in the first step what happened? OH2 positive. Okay, in the first step OH2 positive, then water removes. When we remove water, so we get positive charge over here. Okay, now 4-membered ring is less stable than 5-membered ring, right? 4-membered ring is less stable than 5-membered ring. 5-membered ring. So first 4-membered ring is converted to 5-membered ring. So we are going to break this bond. So here we have negative charge, here we have positive charge. So new positive charge is going to be here. Okay, so let's form a bond. Okay, let's form a bond. So we have 1, 2, 3, 4, 5. Okay, bete. So now we have 2 5-membered rings. So 2 5-membered rings, they are going to be like this. Okay, 2 5-membered ring. So this is the 1-number carbon and this is the 5-number carbon. So positive charge is over here. So here we have 2 degree carbocation. 2 degree carbocation. Now what happens? Here we have hydrogen, 1 hydrogen. So we are going to do hydride shift. Hydride shift. So if we do hydride shift, so we have carbocation over here. Okay, we have carbocation over here. Now what we are going to do? we are going to convert 5-membered ring into the 6-membered ring. So let's break this bond. So here negative, so new positive charge is going to be on this carbon. So let's form a bond. Okay, let's form a bond. So here we have 1, 2, 3, 4, 5, 6, right? So we are going to form 6-membered ring. 6-membered ring. So this is one number. अब now one number membered, मतलब one number is one number carbon is in the 5-membered ring. So let's form 5-membered ring like this. Okay, and we have, this is one number, this is two number, this is three number, this is four number, this is five number, this is six number. So we have positive charge on 6-membered ring. Okay, not 6-membered, not 6 number carbon. Now what happens? Let's break this bond. Let's break this bond. And here we write negative, and now new positive charge is going to be on carbon number 1. So let's form bond, right? Let's form bond. So when we form bond, so we have 6-membered ring now. So one hai, so this is 2 dash, this is 3 dash, this is 4 dash, this is 5 dash and 6. So now let's form 2 6-membered ring. So this is 2 dash, 3 dash, 4 dash, 5 dash. This is 6, 1, 2, 3, 4, 5. Okay. Now we have the positive charge on carbon number 1. So let's put positive charge on carbon number 1. So here positive charge. Now what will happen? Here we have hydrogen. So minus H plus. So electron of this bond shifts over here. So when electron of this bond shifts over here, so we get this as the product. Okay, so now question says, in the above reaction, left hand side and right hand side rings are named as A and B respectively. They undergo ring expansion. The correct statement for this process is, so correct statement for this process is, both ring will become 6-membered each. So option 2 is going to be the correct answer. Okay, option 2 is going to be the correct answer. Now, moving on to the next type of questions. So here we have questions related to physical properties. So let's do this question. The increasing order of boiling points of the following compound is. So we know that boiling point is directly proportional to molar mass. Right, molar mass. Now if we check the molar mass, so second one is going to have more molar mass. Right, more molar mass, because see, this is same in all. This part is same in all. है ना, this part is same in all. So CH3 mass is going to be 12 plus 3, 15. NO2 mass is going to be bete 14 plus 2 into 16. NH2 mass is going to be 14 plus 2, which is 16. And OCH3 mass is going to be 16 plus 12 plus 3. ठीक है, so if we talk about the mass order, so NO2 mass is going to be more, then OCH3, then NH2, and then CH3, right? So more molar mass second, तो second का ज्यादा. Also in second we have hydrogen bonding also. We have hydrogen bonding, intermolecular hydrogen bonding. So second is going to be highest. After second, we should be having fourth one, but fourth one will not be there. It is going to be third one. Why? Due to intermolecular hydrogen bonding. Due to intermolecular hydrogen bonding. So see, if we have OH NH2, so this is OH and this is NH2. And if we write NH2 like this and OH like this, so nitrogen hydrogen bonding, right? Hydrogen nitrogen bonding. So hydrogen bonding is there. Now due to the hydrogen bonding, what happens? Boiling point increases, right? Boiling point is directly proportional to hydrogen bonding. Okay? So in the first one also we have this thing, but we are not going to apply the concept of hydrogen bonding in the second one. That is the nitro group. Why? Because molar mass is also more. Then after third we have fourth, and then we have first. Okay? So answer is going to be second is more, then we have third, then fourth and first. So on the basis of that, option 2 is going to be the correct answer. Clear? Now moving on to the next question. Arrange the following compounds in increasing order of COH bond length. We have CH3OH bete, CH3OH. Then we have phenol, phenol, and then we have para-ethoxyphenol, para-ethoxy, CH2, CH3, phenol. And we have to find out the bond length order of COH bond. It means we have to find out the bond length of CO. This bond length we have to find out. So see how to find out. We know that key if bond length is inversely proportional to bond order. Bond order. Okay. Up now in case of this one, we have no resonance, nothing. So it means here bond order of carbon oxygen is equal to 1. It is equal to 1. Now moving on to this one. So in oxygen we have lone pair and we have double bond in conjugation. So we can form resonance. Right. So we have resonating structure like this. See, negative, double bond OH positive. Then again this charge moves over here and electron of this bond shifts to para position. So we have negative charge on para position. Right. Then again we have negative charge on ortho position. We have negative charge on ortho position, right? Understood. So in that way we can draw the resonating structure. So in OH we have partial double bond character. Partial double bond character. Okay. Now let's check for ethoxyphenol, para-ethoxyphenol. So here we can have resonance. Even resonance can be from here, right? So here we have partial double bond character. Partial double bond character, but to less extent. Why? Because we have two electron releasing group. We have OH and OCH3. So OH-CH3 can give electron, even OH का oxygen can give its electron. So we have partial but to less extent. ठीक है? Less extent. So it means bond length is highest in methanol. So see, we have only one option with respect to that. This. Okay, then we have para-ethoxyphenol, so less double bond character, and in phenol we have more double bond character. Okay, so here less extent. Why? Two electron releasing group present. We have two electron releasing group. Clear? That's it. Now moving on to the next type of question. So we have some questions which are directly related to the preparation. So if we see in the cumene to phenol preparation in presence of air, the intermediate is this. So this is what cumene hydroperoxide reaction, है ना? Cumene hydroperoxide reaction, and in this reaction we can prepare phenol. So what is cumene? Cumene is this. Isopropyl benzene is cumene. ठीक है? So on reaction with O2, what happens? On reaction with O2, what happens? So we have peroxide, OOH. This kind of intermediate is formed. And after that, what happens? This carbon forms bond with this and electron of this bond shifts over here. Understood? So with this, we have phenol and acetone. So this is the naming reaction. You cannot change the product. So first, we have to find out the intermediate. So option 4 is the correct answer. So this is name reaction. Question is based on the name reaction. Okay. Now moving on to the next question. Suitable reaction condition for the preparation of methyl phenyl ether is. Methyl phenyl ether is CH3O, and here we write phenyl group. What is phenyl group? Phenyl group is C6H5, or how do we write phenyl group? Phenyl group is this. Okay, this is phenyl group. So we have to form this one. So how to find out? So see, we have first PHO minus Na plus, and we have MEOH. It means CH3OH. Okay, so what happens? CH3OH. Okay, so if we want to form ether, so see, O minus should attack over here and this should leave now. But how do we remove this? This is not possible. Not possible. OH is a poor leaving group. We cannot remove OH. ऐसे नहीं remove कर सकते. We cannot remove OH. So if we want to remove OH, right, the acidic medium should be present so that it is converted to CH3OH2 positive and then OH2 can remove, right? Then this can happen. Otherwise, so no. Otherwise, no. Clear? Otherwise, no. Or what we can do, if we have kuch alcohol, so first we have to react this with tosyl chloride. So it is converted to CH3OTS and then OTS can leave. So in that way, OH can be removed. Otherwise, it is not possible. So from first one, we cannot prepare. Now second, we have benzene plus MEBr. So we have benzene plus MEBr. First of all, for this, we should be having reagent anhydrous AlCl3. So for that, we get the carbocation this and we get AlCl3 and here we get Br and this is minus. But this is going to be electrophilic aromatic substitution. So here, from here, we get toluene, right? From here, we get toluene, not ether. Now check for the third option, PHBr plus PHBr, let me write it like this, PHBr and MEO minus Na plus. We know that nucleophilic attack is difficult on benzene ring, so no reaction, right? So no reaction. Clear? ठीक है? That's it. अच्छा, यहाँ पे from the first one, which product we are going to form? If we want to form the product from here, so what happens? Here we have CH3O minus or H plus, na? So PHO minus takes H plus, right? And we get phenol plus CH3O Na. Understood? So we get phenol from here. Up now we have only the fourth option. So let's check for the fourth option. So fourth option is PHO minus Na plus and this is CH3Br. So bete the reaction, this is Williamson synthesis, ether synthesis. Williamson ether synthesis. So O minus attacks on the CH3 and Br leaves and we get PHOCH3 and with that we get NaBr. So we get methyl phenyl ether. So this is going to be the correct answer. Okay, this is going to be the correct answer. Now, moving on to the next question. The products formed in the reaction of cumene with O2 followed by treatment with dilute HCl. Phenol and acetone. Without any doubt. Without any doubt, phenol and acetone. Clear? Next, incorrect method of preparation of alcohols from the following is reaction of ketone with RMGBr. So already discussed this part. If we have ketone, right, ketone, and we have RMGBr, Grignard reagent, so we get alcohol. We get alcohol, right? So R negative, magnesium positive. So this is positive and this oxygen negative. So R minus attacks on this carbon. Then electron of this bond shifts to oxygen and then oxygen forms bond with this Mg, right? So we get CH3COMgBr, CH3 and this is R. And then on hydrolysis, we are going to break this bond. So here we write OH, here we write H. Why? Because oxygen is more electronegative and magnesium is positive. So we get 3-degree alcohol. So CH3, COH, CH3 and R. Right? तो ये तो true है. This is true. Correct one. ठीक है? Second, reaction of alkyl halide with aqueous NaOH. Yes, we can do simply nucleophilic substitution reaction. So when we do nucleophilic substitution reaction, so OH minus attacks on R and X leaves. So we get ROH plus NaX. So from that also we can prepare. So this is correct one. Now, third one, hydroboration oxidation of alkene. Yes, if we have alkene, so hydroboration oxidation means B2H6, B2H6, and then we have H2O2 and NaBH4, or we can say B2H6 in presence of OH minus, and then we have NaBH4. So we have anti-Markovnikov of addition and we get alcohol. So this is correct. Answer is fourth, ozonolysis of alkene. Because if we say ozonolysis, na, so we generally talk about reductive ozonolysis. Right? So generally talk about reductive ozonolysis. So if we have alkene, right? If we have alkene, so on ozonolysis, we have ozonide formation. Ozonide formation means we are going to form heart-shaped structure, right? Heart-shaped structure, and then in the presence of ZnH2O, we are going to break this bond, right? So here we form a double bond, and here we form double bond. So here we get CH3, C double bond OH plus H, C double bond OH. So from ozonolysis, we get either aldehyde, or ketone. ठीक है. Or if we have oxidative ozonolysis, suppose if we have oxidative ozonolysis, then aldehyde is converted to carboxylic acid, and ketone as it is. Clear? So we do not have alcohol from ozonolysis. We are going to have aldehyde, ketone, or carboxylic acid. So option 4 is going to be the correct answer. Clear? That's it. Now we are moving to the next type of questions, in which we have questions related to the chemical properties of alcohols, phenols, and ether. So now let's do question number 1. So question says A and B formed in the following set of reactions are. So in the first one, what do we have? We have phenol, and on meta position we have CH2OH, है ना? CH2OH, see, CH2OH, and here we have OH. Now what happens? HBr. So we are not going to do addition reaction. We are going to do substitution reaction. So here nucleophilic substitution is difficult. Nucleophilic substitution on benzene ring is difficult. Is difficult on benzene ring. Is difficult on benzene ring. So what happens over here? Lone pair on oxygen, it takes H plus and Br leaves, and due to this we have OH and CH2 OH2 positive, right? Right. So now what happens? Br minus attacks on this carbon and OH2 leaves, and we have the formation of OH2 and CH2Br. Clear? OH and CH2Br. Now second, we have OH and OCH3. We have OH, and on meta position we have OCH3. Yes, we have OCH3. Now this is HBr. Now we have ether. So this is a reaction of ether. Oxygen takes H plus. We write OH. Here we write OH positive and then CH3. Okay. Now this Br minus, right? It will do SN2 attack generally. It will do SN2 attack. So Br minus attacks on less strictly hindered carbon, and electron of this bond shifts to OH. So we get OH and OH. With that we get CH3Br. Right? We get CH3Br. Let me rewrite this bit. Let me rewrite this. We get OH, OH plus CH3Br. Okay. So if we see the correct options, so from the first we have OH and CH2Br, and in the second one we have OH and OH. So option 4 is going to be the correct answer. ठीक है? Option 4 is going to be the correct answer. Clear? Now let's do the next question. So find out the major product from the following reaction. So concentrated H2SO4 and heat, it means we are going to form alkene, and this is the reaction of dehydration. This is a reaction of dehydration. Now if heat is also given, if heat is also given or temperature is too high, so we have to form thermodynamically controlled product. We have to form thermodynamically controlled product. It means most stable product. Most stable product. Okay? And we know that in this product we have alkene. So which alkene is more stable? Sadzef alkene, or we can say more alkylated alkene is the more stable. Why? Due to more alpha hydrogen, and more alpha hydrogen means more hyper conjugation. More hyper conjugation. So just try to understand this. So we have this. Let me write here 2 methyl, here 1 methyl, and here we have OH. Okay, so first H plus and HSO4 minus. Now what we are going to do? Oxygen lone pair attacks on this H plus, HSO4 leaves, and we have OH2 positive formation. Now on removing this, we get 2 degree carbocation, right? We get 2 degree carbocation. So up here we are going to do two things. So here hydride. So hydride shift is faster than methyl shift. If we do hydride shift, we get this carbocation, 3 degree carbocation, right? If we do hydride shift, we get this 3 degree carbocation, right? 3 degree carbocation. Up now we have beta hydrogen. So we have hydrogen over here, we have hydrogen over here, even we have hydrogen over here, right? So from this we can have three products, right? From this we can have three products. But if I'm going to form more stable product, so from this case we write this, and this. So we can write this as the product, right? We can write this as the product. Up now heating is given, so we have to think like, can we form another stable product? So it means if we do methyl shift, see here, right? We are going to do methyl shift over here. Okay, so what happens? We get this carbocation, and here we have methyl, and here we have methyl. Clear? Up now we have the hydrogen. So see, we have hydrogen, one hydrogen is over here. Up now if I remove this hydrogen, we have one hydrogen over here, right? But if I form the more alkylated alkene, so that is going to be over here. Okay, now let's compare this. This. So we have 1 alkylation, 2 alkylation, 3 alkylation, right? And if we see this one, 1 alkylation, 2 alkylation, 3 alkylation, 4 alkylation, right? So here this is going to be the more alkylated product, so that's why we have to do methyl shift, right? More alkylated product, that's why we have to do methyl shift, not hydride shift. Okay, so it means answer is going to be first, not fourth. Otherwise we can have all the product, we can have option number 2, we can have option number 3, 4. All products are possible. All products are possible in this case, but most stable, most thermodynamically controlled product is option number 1. Okay, now moving on to the next question. In the following reaction, aldehyde plus alcohol. See, we have aldehyde, suppose we have this one, or we can simply say we have aldehyde R C double bond OH, and we have alcohol R dash OH. So what happens? Nucleophilic addition reaction. So oxygen lone pair attacks on this carbonyl carbon, and electron of this one shifts towards oxygen. So we get R O minus, this is H, and here we write O positive R dash, right Pite? O positive R dash, and here we have H. Now this oxygen takes this H plus, so we get R CH OH and OR dash. So it means this reaction is what? Nucleophilic addition reaction. Nucleophilic addition reaction. Okay. Now nucleophilic attack, yani nucleophilic attack is on aldehyde. It means this carbon should be more electrophilic, or less nucleophilic. Then only it is possible, na? So see, we have to choose the aldehyde and alcohol. So we have two aldehyde. we have HC double bond OH, and we have CH3 C double bond OH. So here we have which effect? See, एक minute, let me rewrite this. Yeah. So if I write this H H H C double bond OH. So here we have hyperconjugation. This is alpha carbon. So here we have alpha hydrogen. So this bond shifts over here and electron of this bond shifts over here. So we get CHH H positive double bond CO minus H. So this is plus H. This is how we draw hyperconjugation. So here we have plus H. In CH3C double bond OH we have plus H. Here no plus I or plus H. So due to plus H, this carbon is less electrophilic and more nucleophilic, right? So we can say on this aldehyde nucleophilic addition is faster. Nucleophilic addition is faster. So here we have option number, matlab aldehyde is this. अब now we have to check for alcohol. So alcohol में we have CH3OH or we have tert butyl alcohol, CH3C, CH3, CH3 and OH, right? So this is going to act as base. It will not act as nucleophile. Why it is not going to act as nucleophile? Because bulkier है. So nucleophile are those substances ना which can easily move and attack on electrophilic position, right? But if we have the bulkier nucleophile, so it cannot move easily. So here we have less nucleophilicity character and more basic character. So here CH3OH is going to be better nucleophile. ठीक है, so which the best combination is going to be option number 2. Clear? And this is also the reaction of aldehydes ketones, है ना, in which we have the formation of acetal. ठीक है बेटे, this is acetal, hemiacetal, this is hemiacetal. ठीक है, that's it. Now let's do next question. The major product of the following reaction is this. It means first of all we have to identify which reaction is this. So this is the reaction of ethers. This is the reaction of ethers. So if we have ROR dash, this is ether, on reaction with HI, then what happens? Oxygen lone pair takes H plus and iodine leaves. So we get ROH positive and R dash plus I minus. So generally now this attack is going to be SN2. So I minus attacks on less sterically hindered position. Right? So if I'm saying कि R dash is less sterically hindered, if assume कर रही हूँ, let me assume R dash is less sterically hindered. So here I minus attacks on this R dash and this bond is going to break. So we get ROH plus R dash I. Right? We get ROH plus R dash I. Now question is excess HI. So if we have excess HI, so ROH can be converted to RI, na? It can also be converted to RI. So we have to apply same concept, but we have to understand one thing over here. If carbocation is more stable, if somehow, notice that if somehow we can form more stable carbocation, then reaction proceeds via SN1. Right, so this part we have to understand. Okay, this part we have to understand. Okay, now on the basis of same concept, let us do this question. So how to do this question? If we have this one, this is going to be this one, bache. So we have C triple bond N. Here we have O, and here we write O. ठीक है. अब now we have excess HI, right? We have excess HI. So how to solve? See, oxygen lone pair attacks on this H and I leaves. Similarly, we can have second equivalent of HI. So this oxygen can attack on this H plus and I leaves. So I can say we can write OH positive and this one. Then C triple bond N and here OH positive. Now this one. Up now we have to do the attack. So I minus can attack over here on this carbon. On this carbon I minus can attack. Why? Because nucleophilic attack over here is impossible on benzene. It is not possible, right? So I minus attacks over here and electron of this bond shifts over here. ठीक है. अब similarly I minus another I minus it attacks over here. Why? Because this is electron withdrawing group. So if this is electron withdrawing group, so this carbon is more electrophilic. This carbon is more electrophilic, right? Then it attacks over here and electron of this bond shifts over here. So on the basis of that, we get OH, then C triple bond N and I plus CH3CCH3 and here we write OH. Here we write OH. So we have excess HI na, so excess HI. Here we cannot do nucleophilic attack. No nucleophilic attack on this position, right? No nucleophilic attack. No nucleophilic attack over here, right? Then what we are going to do? Here OH can be replaced with iodine. So we get OH CNI plus CH3CCH3H and this is going to be I. Clear? So this is going to be the final product. Now let us match with the correct option. So Cn and I and we have OH. So option number 2 is the correct answer. Okay, bete, that's it. Okay. Now moving on to the next question. So next question is this. So we have CH3O, CH2, CH2, CH, CH3 and we have AlCl3. What is the role of AlCl3? What is the role of AlCl3? It's a Lewis acid. It's a Lewis acid. So what happens? Cl lone pair na, Cl lone pair goes to the empty orbital of aluminium. Aluminium has empty orbital, so it goes to the empty orbital of aluminium. So from that, what do we form? We can form CH3O, CH2, CH2, CH positive, and here we can write CH3. Okay. Ab now what we can do? See, this is 2-degree carbocation, so we have to check whether we can do some kind of rearrangement or we can do ring expansion, ring contraction and all. If you see this carefully, we have benzene system, we have double bond, so we can do ring expansion. Okay, we can do ring expansion and electron of this bond if shifts over here, then mu positive charge generates onto this carbon and we are going to form bond like this. So by doing so, we get 1, 2, 3, 4, 5 and 6 membered ring. So let us form 6-membered ring. So we have CH3, this is O, CH2, CH2, CH and CH3. New positive charges over here and this is going to be the next product. Now positive charges there, so here we have hydrogen, so AlCl4 minus, right, it takes this hydrogen and electron of this bond shifts over here, and when this is going to happen we get option number 3 as the answer. ठीक है, we get option number 3 as the answer. Clear? Okay. Now moving on to the next question. We have major product of the following reaction is, so we have this one. So we have OH, ठीक है, ortho and meta. Ortho and meta we have CH2 CH2 CH2OH, CH2 CH2OH. ठीक है, CH2 CH2 CH2OH. अब now we have what? CrO3. We have what? CrO3. So what is the role of CrO3? Here it should also be given CrO3H plus. So see, this is 1 degree alcohol. So this 1 degree alcohol, this is a kind of Jones reagent, na? CrO3 and H plus. So 1 degree alcohol is oxidized to carboxylic acid, right? So let me write carboxylic acid. So here we write OH, then CH2 CH2 CH2, right? Matlab C, then we have double bond O and this OH. Clear? Okay. Next we have SOCl2 and heat. So SOCl2 in heat, so this is the chlorinating reagent. So this is chlorinating reagent. So if this is the chlorinating reagent, so if we have C double bond O OH, so in the presence of this we get C double bond O Cl. Reagent based question is this. So let me write the next product. So we get OH double bond O and Cl, double bond O and Cl. Fine. Now we have to do heating. Now heating means, it means we have to do some kind of rearrangement. We can do elimination and all if it is possible. Okay, if it is possible. Now if you see this, right? So how can we remove? How can we remove this? Yeah, how can we remove Cl? Because Cl is the leaving group, right? Cl is the leaving group. Okay. A point is that if this attacks over here, so we have positive charge generation over here, right? Positive charge is more stable in presence of OH because OH shows resonance, right? So this is electron reducing group. So what we can do over here, we can write this in a different way, right? We can write this in a different way, and I'm going to write the structure like this. Okay, so this is OH, 1, 2, this CH2, 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 then double bond O and Cl. Okay, clear? Okay, up now if this is going to attack over here, so Cl leaves. So we are going to form ring. So here negative charge, right? We are going to form 5-membered ring. And here we have the generation of positive charge. Now let's form the ring. So what we are going to write? We are going to write OH positive over here, then 2, 3, and this. Okay. So we have hydrogen. Now that Cl minus, it takes this hydrogen and electron of this bond shifts over here. So we get OH, then okay, so we get this as the answer. Just try to understand why we are not going to form ring like this. See, we can also form ring like this, na, OH, and we have positive charge over here, and then we can write double bond O, and we can write this thing. Okay, so we cannot do this, right? We cannot do this. Why we cannot do this? Ki now the positive charge is very far from OH, right? Due to the formation of ring. Here, if we form positive charge over here, so it is more stabilized, right? It is more stabilized. Is it clear? So that's why what is going to be the answer? Our answer is going to be option number 2. Not option number 1, option number 2. Okay. Now, moving on to the next question. So we have this OH and Cl. This is CHCl3 and aqueous NaOH. This is Reimer-Tiemann. So from Reimer-Tiemann, what do we get? We get ortho position पे CHO. right, or para position पे. Ortho one is more stable, major one. Why? Due to the intramolecular hydrogen bonding. Due to intramolecular hydrogen bonding, right? So we have this one. ठीक है. अब now we have OH and CHO. एक मिनट, let me rewrite. OH, CHO, and here we have Cl. Now this is treated with HCHO and concentrated NaOH. HCHO and concentrated NaOH. Now if you try to understand, here we do not have alpha hydrogen, no alpha hydrogen. This is alpha position and no alpha hydrogen, and in this also we do not have alpha hydrogen. Concentrated base is there, it means we have to perform Cannizzaro reaction. So what is the way to memorize? In Cannizzaro we have redox reaction. So the smaller one is converted to carboxylate or carboxylic acid salt, and bigger one is converted to alcohol. So this is the bigger one, right? This is bigger one. So this is the trick basically. So here we write OH, CH2OH, and this is Cl plus HC double bond O minus Na plus. Clear? So we get this. Now next one is HCO positive and heat, right? HCO positive and heat, HCHO, NaOH, and then we have HCO positive है. तो HCO positive में this carboxylic acid salt is converted to formic acid. ठीक है? So we get formic acid and this as the answer. So let us find the correct option. So OH, CH2OH, Cl, and formic acid. So as per our answer, option 4 is going to be the correct answer. Clear? Now moving on to the next question, we have what will be the major product when metacresol is reacted with propargyl bromide. Metacresol. So OH and CH3. ठीक है? So this is metacresol. Reacts with what? Propargyl bromide. So CH triple bond C and this is CH2Br in presence of K2CO3 in acetone. Right? So see, what is K2CO3? So K2CO3 is formed from KOH, which is the strong base, and formic acid H2CO3, which is the weak acid. So it means this K2CO3 is the base. And if it is the base, so its main work to abstract hydrogen. Its main work to abstract hydrogen. Then acetone is given, it means we have to perform SN2 reaction, right? We have to perform SN2 reaction. So how to solve this? See, we have OH, CH3, then in the presence of base, what happened? Hydrogen, we are going to remove hydrogen. So when we remove hydrogen, we get O minus, and at meta position we have CH3. Then we have propargyl bromide, right? We have this one. So acetone is there, it means we have to do SN2 attack. So this is 1 degree alkyl halide, right? This is 1 degree alkyl halide now. This is 1 degree alkyl halide. So we have to do SN2 attack. So we get O minus is going to attack on CH2 and Br leaves. And from that, what do we get? We get this OCH2, C triple bond CH and CH3. Clear? So we get this as the answer. So let us find out the correct answer. So we have O, CH2C. Option 1 is going to be the correct answer. Clear? Option 1 is going to be correct answer. Now moving on to the next question. We have heating of 2-chloro-1-phenyl butane. So 2-chloro-1-phenyl butane. So 2-chloro and 1 पे we have phenyl group C6H5, or we can also write phenyl as PH. ठीक है? So we have CH3, CH2, CH and CH2. ठीक है? So heating of this with ETOH and ETOK. So this is what? Alcohol and base. So it means we have to do elimination reaction. We have to do elimination reaction, bete. So let us do elimination reaction. So what happens? We have Cl leaves. So we write CH2, CH positive, then CH2, CH3. Now what we are going to do? We have to do hydride shift over here. Hydride shift. So hydride shift say we get benzylic carbocation. We get CH positive, CH2, CH2, CH3. Now this is benzylic carbocation. Benzylic carbocation is resonance stabilized, right? It is resonance stabilized. That's why we have done the shift wala part. ठीक है? अब now we have to form Setzef alkene, right? Setzef alkene. So where do we get alkene? So from where we are going to form alkene? So see, we have this phenyl, we have C, okay, H positive, double bond C, H, and then not double bond. Let me write C positive, H, then CH2, CH2, CH3. ठीक है? We have to form alkene. So what happens? OET minus abstract. This is alpha carbon, this is beta carbon, na? So OET minus abstracts this, and electron of this bond shifts over here, and we get phenyl C, H, double bond C, H, and CH2, CH3. So we get this alkene as the major product. Okay. Now, reaction of X with HgOAc2 H2O followed by NaBH4. So basically, HgOAc2 water and followed by NaBH4. This is OMDM, oxymercuration demercuration reaction, and for this we have to do Markovnikov attack. Markovnikov attack without rearrangement. So we form phenyl COH, CH2, CH2, CH3. Okay, so here we have to do attack. So as per this, which is going to be the correct answer? Phenyl CHOH, then CH2, CH2, CH3. So option 3 is going to be the correct answer. Clear? Option 3 is going to be the correct answer. Now moving on to the next question. So we have this thing, Br2. So what is the role of Br2? Br2 adds across the double bond. So here we cannot add Br2. Why? Because this ring is aromatic. So we are going to add Br2 on ring number 2. So here we are going to do addition, and we are having Br positive and this bromonium ion. We have now ETOH, ETOH minus ETO minus plus H plus. So nucleophile is this. So here also we have to do Markovnikov only, right? Markovnikov. Okay. So this is the benzylic position, right? This is benzylic position. So this is more stable. So OET minus attacks over here, and electron of this bond shifts over here. So from this, what do we get? We get OET over here and Br over here. Okay, so this is going to be the correct answer, and option number 1 is the correct one. Clarity? Okay. Now, moving on to the next question. So we have this benzene ring, then we have OH, this, then NH2 and this. Then we have anhydride, CH3, C double bond O, C double bond O, CH3 in the presence of pyridine. So what is the role of pyridine? So pyridine is a base basically, है ना? Base है. Pyridine is a base. ठीक है? अब now room temperature पे we have to do the reaction. So what happens? Pyridine takes hydrogen from NH, right? NH2. So we get OH, this, NH negative, and this. Up now this NH negative attacks on this carbonyl carbon, and this bond breaks. So we have OH, this, NH, C double bond O, CH3, right? This reaction is also used to protect amino group, right? This reaction is also used to protect amino group. This is called acylation reaction. This is called acylation reaction. Now the point is that, see, we have alpha position and beta, we can remove water, but here room temperature is given. So at room temperature we are not going to do elimination, so no elimination. So from that point of view, option number 4 is going to be the correct answer. Clear? Okay. Now moving on to the next question. Which is the most suitable region for the following transformation? So we have this CH3, CH, double bond CH, then CH2, CHOH, CH3. Now this is converted to CH3, CH, double bond CH, then CH2, COOH. So this part is same, right? So it means this whole part is converted to this one. Okay. So basically, tolerance reagent is used to oxidize aldehydes. Oxidize aldehydes. So first, incorrect. Then we have I2NaOH. So this is the haloform reaction, and in the haloform reaction, this is the iodoform reaction. So what happens in iodoform reaction, and what is the condition, right? So we should be having this group CH3 C double bond O, this group, or we can say we should be having this group. ठीक है. So what happens when you have this group? Suppose we have CH2 and CH3. So if you react this with I2 and OH minus, then what happens? This is going to break. This whole part is converted to CHI3. We get iodoform, yellow color precipitate, and that part CH3, CH2, C double bond O minus, right? So this is converted into this form. Okay, so now the point is that we have this group CH3CHOH. So first it will oxidize to this one, right? When it oxidizes to this one, so we have methyl ketones. So you have to break from here. So when you break from here, so you get CH3CH double bond CH, then CH2 C double bond O minus Na plus CHI3. Understood? It means first we are going to write this thing CH3CH, then CH2 C double bond O CH3 on oxidation, right? And then we get this one. So it means answer is going to be option number 2. Answer is going to be option number 2. Okay, we cannot use third one because third one is CrO2 Cl2 CS2. So this is again mild oxidizing agent. So we have 2 degree alcohol. So 2 degree alcohol is converted to ketone. And alkaline KMnO4, again 2 degree alcohol is converted to ketone. If we want carboxylic acid, so we must do haloform reaction, and for haloform reaction we must have methyl ketones which or isopropyl alcohol which is there. Okay, not isopropyl alcohol, we should be having the secondary alcohol part. Understood? So this is going to be answer. Now moving on to the next question. So we have, this is the reaction of phenol. So we have OH, and this is we have SOO, and this is OH. Okay, this is a good leaving group. This is the good SO3H na, SO3H, yeah. So this is going to be a good leaving group. So we have Br2 in excess, Br2 in excess. So see, this is electron releasing group. This shows plus M effect, right? This shows plus M effect, but this shows minus M effect. So this activates the ring. So if this activates the ring, so we get ortho and para directing. Ortho and para directing. Para position is occupied, right? Para position is occupied. So first we are going to write ortho par. We are going to put Br, and here we have SO3H. It's a leaving group, and we have Br2 in excess. So if we have Br2 in excess, so what we can do? We can attach Br over here also. Okay? So we can attach Br over here also. Understood? So answer is going to be option number 1. Clear? Now moving on to the next question. The major product of the following reaction is. So we have HCl and anhydrous AlCl3. Okay? So see, we have OH, and this is ortho and this is meta. Meta पे we have CH2 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 CH2, so CH2 CH2 then CH double bond CH2. Understood? Up now we have HCl. We have HCl. So oxygen lone pair can attack on H plus. Even this double bond can attack on H plus. Okay. So carbon is less electronegative. Carbon is less electronegative. So pi bond can attack. Pi bond can attack. So this will not happen. This is going to happen. And when this is going to happen, what we will do? OH, this is the positive charge over here. We are going to do Markovnikov thing, right? Markovnikov thing. So we get 2 degree carbocation, right? We get 2 degree carbocation. Now next thing, what we are going to do, what we can do, we can form ring, right? We can form ring. Okay. So up two things can happen. Two things can happen. See, this is 1 number, this is 2 number, this is 3 number, this is 4 number, this is 5 number. Okay, this is 5 number. Up the point is that, let me rewrite this. So if we have 1, 2, this, we have OH over here, then CH2, CH2, CH, CH2, CH2, CH, and here we have positive charge. So 1, 2, 3, 4, 5. Our point is that if this carbon forms bond with this carbocation, so we have positive charge generation over here, right? Right? If fifth carbon forms bond with carbocation, then positive charge generates on fourth carbon, right, which is away from OH, and OH is what? It shows plus N, so it stabilizes carbocation. Now we can have other situation also. What is the other situation? See, what we can do, I can rewrite this compound in that way. OH, CH2, CH2, CH, this is positive. Now, if this carbon forms bond with this carbocation, so 1, 2, 3, 4, 5. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Okay? So, if 5 dash carbon forms bond with carbocation, then positive charge is on 4 dash, which is closer to OH. So this is going to happen, right? So this is going to happen. So let's form a ring. So if I'm going to form a ring, so we have OH over here, okay, positive charge over here, and from here we can form 5-membered ring, right? We can form 5-membered ring. Let me write this over here. Okay, OH, positive charge on 4th number, and then we form 5-membered ring. So this is 5 dash number carbon, and this is 1 dash number carbon, and 1 dash number carbon is bonded to CH3. ठीक है बेटे? Is it clear? So we have this situation. Ab now this Cl minus leaves na, so Cl minus combines with AlCl3 to form AlCl4 minus. ठीक है? We have empty orbital on aluminium, so Cl minus give its electron to aluminium. So we have AlCl4 minus. Now see, we have hydrogen on 5 dash carbon. So what happened? AlCl4 minus abstracts this hydrogen, and electron of this bond shifts over here. So by doing so, we get this, right? So this is going to be the answer. Now let's find out the correct answer. So if we see, so this is one number, the 2, 3, 4, 5, 6. On 6th number carbon we have methyl group. So just see, let's look for option number 4th. So if we have one number, the 2, 3, 4, 5, 6. So on 6th number we have methyl group. So 4th answer is going to be the correct one. Okay, 4th option is going to be correct one. Now moving on to the next question. The major product B in the following sequence of reaction. If you see the reagent, this is hydroboration oxidation. Hydroboration oxidation. And hydroboration oxidation is used to oxidize alkenes to alcohol. But here we have to do anti-Markovnikov addition. Okay. So what do we get? We get CH3, CH, CH3, CH3. Here we write H and here we write OH. Then CH2, CH3. Okay, so this is A. This is A. Now we have dilute H2SO4. Dilute H2SO4 and heat. It means we have to do dehydration. We have to do dehydration, and from dehydration we should be getting alkene. We should be getting alkene. So first step is what? What is the first step? We have H plus and HSO4 minus beta. So oxygen lone pair attacks on H plus and HSO4 leaves. So due to this we get CH3, CH, C, CH3, CH3, right? Then CH, OH2 positive, and here what we can write? CH2, CH3. Now water is a good leaving group, so water leaves, right? Water leaves minus H2O. So we have the generation of carbocation. CH3, CH3, then CH positive, and then CH2, CH3. So this is 2-degree carbocation. Now if we do hydride shift, if we do hydride shift, then we get more stable carbocation, 3-degree, CH, CH3, CH3, here we write CH2, CH2, CH3. Okay, now HSO4 minus abstracts hydrogen, beta hydrogen. So beta elimination होगा ना. So here we have hydrogen over here. ठीक है, we can have hydrogen over here. Even we can have this hydrogen. ठीक है. So in order to form Sedgwick product, we have to remove green hydrogen. So for Sedgwick product, remove green hydrogen. So we get CH3, C, double bond C. Here we write CH3, here we write CH3, and here we write CH2, CH2, CH2. So see, 4 alkylation, 3, 4, right? So this is going to be the Sedgwick product. So obviously we have to write down the major product. So answer is going to be option number B. Clear? So we have to write down the Sedgwick product. Question says the major product. So Sedgwick product is going to be the major product. Now next, the major product of the following reaction. So we have concentrated HBr excess, but this is in excess. So we have OCH3 and we have CH double bond CH2. So now HBr है ना, तो concentrated HBr in excess. So I'm going to write in, I'm going to write 2 equivalents because ether can react, even this double bond can attack. ठीक है? So what do we get from here? We get OH positive, then CH3 beta, and here we get CH positive and CH3. Okay, now we have the role of Br minus. So what is the role of Br minus? So here Br minus do acid 2. So Br minus attacks on CH3 and electron of this bond shifts over here. And here Br minus attacks over here. Okay, this is simply the nucleophilic attack. Okay, so we get OH plus CH3Br and from here we get CHBr and CH3. ठीक है? So on the basis of that, option 2 is the correct answer. On the basis of that, option 2 is going to be the correct answer. Now let's do next question. So we have questions is the major product of the following reaction are. So reagent based question is this. So we have butoxide, potassium third butoxide, which is this CH3, C, CH3, this is CH3 and O minus K positive, right? So under this we have to do elimination reaction, elimination reaction, elimination reaction, but Hoffman product is the major product. Hoffman product is major product. And what is Hoffman product? Less alkylated alkene. Less alkylated alkene. So here what is the leaving group? Beta, this starts from oxygen na? So any group which starts from oxygen, that is going to be a leaving group. So this is the leaving group. We have leaving group over here. So when leaving group leaves, minus OSO2CH3, right? So we get CH3, CH, CH3, now CH positive CH3. So we have to do Hoffman elimination, na Hoffman. So obviously we have to remove this hydrogen. Remove orange hydrogen to get Hoffman product. To get Hoffman product. So what do we get? We get CH3, CH, CH3 and then CH double bond CH2. Okay? What do we get? CH3, CH, CH3 and CH double bond CH2. Now next reagent is O3 and H2O2. O3 and H2O2 is oxidative ozonolysis. Oxidative ozonolysis. And here what do we get? We can get either carboxylic acid or ketone बच्चे. So what do we do? What is the trick? Just break this, put oxygen. So we get CH3, CH3, now C double bond OH plus H, C double bond OH. Now both are aldehyde, so aldehyde they are oxidized to carboxylic acid. Okay, so aldehydes are oxidized to carboxylic acid, but ketones ka oxidation is difficult. So if we get ketone from ozonolysis, so ketone remains ketone. Okay, so from that part, we get option number 4 is the correct answer. Clear? We get option number 4 is the correct answer. Now moving on to the next question. We have a solution of phenol in chloroform. So phenol is OH and chloroform is CHCl3. When treated in the presence of aqueous NaOH, gives compound P. If you see the reagent, this is the Reimer-Tiemann reaction. है ना? Reimer-Tiemann reaction. So from this we get CHO at ortho position as the major product. Why it is the major product? Due to intramolecular hydrogen bonding. Okay. So we have to find out mass percentage of carbon in P. So this is P. So what is the molar mass of P? So first we have to find out molar mass of P. So we have 5, 6, 7. 7 carbon. So 7 into 12, that is carbon ka. Then we have hydrogen. How many hydrogen we have? 1, 2, 3, 4, 5, 6. 6 hydrogen. So plus 6 into 1 and 2 oxygen, yani 2 into 16. ठीक है? So when you calculate this, you get 122 gram. ठीक है? Now percentage of carbon, mass of carbon divided by mass of compound into 100. So mass of carbon is 12 into 7, 122 into 100, which is equal to 84 upon 122 into 100. and so on solving this you get 69%. Understood? You get 69%. The answer is going to be 69. Around 68 point something आएगा, you get 68 point something, but round off करके you can write it to 69%. Clear? That's it. Now let's do next question. We have one methyl ethylene oxide. So what is ethylene oxide? Ethylene oxide is this bit. This is ethylene oxide. ठीक है? This is ethylene oxide. And if we have one methyl ethylene oxide, so this is going to be this one. When treated with excess of HBr, so see, this is ether na. Ether shows one kind of reaction. Oxygen ka lone pair attacks on H plus and this Br leaves. So we have OH positive and here we have CH3. ठीक है? Now this Br minus, it do SN2 attack. It means it attacks on less sterically hindered carbon. Attacks on less sterically hindered carbon. So it means Br minus attacks on this carbon and this bond electron shifts to oxygen. So we get Br, here we have CH3 and here we have OH. ठीक है, but we have excess of HBr है ना, तो we get CH3, CHOH and CH2Br. But we have excess of HBr, so if we have excess of HBr, so we can do nucleophilic substitution over here. We can do nucleophilic substitution, ठीक है, over here. So from here we get CH3, CHBr and then CH2Br. Understood? Got it? So let's find out the correct answer. So we get CH3, CHBr, then CH2Br. So option 2 is going to be the correct answer. CH3, CHBr and then CH2Br. Clear? ठीक है. Now let's do next question. In the following reaction sequence, structure of A and B respectively will be. ठीक है? So we have this one. Oxygen. Here we have CH2Br, HBr and heat. Ether ka reaction, oxygen, then Br leaves and we get OH positive and here we write CH2Br. Ab now Br minus attacks on this carbon and electron of this bond shifts to oxygen. Why? Because Br minus cannot attack over here. Nucleophilic substitution is difficult on benzene ring. ठीक है? So what do we get from here? We get CH2Br. Let me write this on the next page. So we get CH2Br. ठीक है? This is basically A. So A is CH2Br. Here we write OH. This is ortho पे OH है ना? Ortho पे OH. ठीक है. Meta पे OH. CH2, CH2, CH2Br. So here we write CH2, CH2, CH2Br. Clear? Now, next, this is A. Next, Na in ether and we have to form intramolecular product. Yani from the same reactant we have to write down the product. So we have Na ether. So this is going to be the Woods reaction. But we have to write down intramolecular product. And we know that intramolecular reaction is faster than intermolecular reaction. Okay, so what happened? Just remove Br and just remove Br and join this. So we get 1, 2, 3, 4, 5, 6. So we get 6 membered ring बच्चे. ठीक है? So here we write OH and here we can form 6 membered ring. Clear? That's it. So this is going to be B1. Now match the correct option. So what do we get? OH, CH2, CH2, CH2Br. Option 3 is the correct answer. Okay. That's it. Now let's do the next question. The major product of the following reaction is. So how to do this? So we have dilute H2SO4. So we have CH3, CH3, double bond, then this CH3, then double bond, and here OH. So first we have H plus and HSO4 minus na. So oxygen lone pair attacks on H plus and HSO4 minus leaves, right? So HSO4 minus leaves. So we get OH2 positive. Okay. Then water leaves. So when we remove water, so we get CH3, CH3, double bond, this, then CH3, double bond, and here we have positive. Okay. Up now we have to find out, see, this is resonance stabilized carbocation. Okay, this is resonance stabilized carbocation. Resonance stabilized carbocation. See, है ना? We have resonance stabilized. So now what we are going to do, if you see the options, so we can form the ring. See, we can form the ring. So ring expansion can happen. So this is 1 number, 2 number, 3 number, 4 number, 5 number, and 6 number. So 6-member ring is more stable. So we are going to form ring from 6 number carbon. So we will have positive charge over here. Understood? We will have positive charge over here. So let's form 6-membered ring. So if we form 6-membered ring, so suppose this is 1 number carbon, this is 2, between 2 and 3 we have double bond, and third way we have methyl group, then we have 4, this is 5, and this is 6 number, and here we have positive CH3 and CH3. So we have positive charge over here. Understood? Okay. अब now heating is not given. So heating is not given. Heat is not given. So if heat is not given, then we cannot do elimination reaction. So here we have to do substitution reaction. है ना? Substitution reaction. We have aqueous H2SO4 ना? We have aqueous H2SO4. So aqueous H2SO4 or dilute H2SO4 है. So what we are going to do? We have nucleophile is going to be OH minus. So what happens? OH minus attacks over here, and by this we get option number 3 as the correct answer. Okay? So we get option 3 as the correct answer. Now let's do next question. So we have an organic compound A. Molecular formula C6H12O2 was hydrolyzed by dilute H2SO4 hydrolyzed to give a carboxylic acid which is B, and alcohol which is C. So it means this must be ester, है ना? The above compound, it must be ester. Now next, C gives turbidity immediately. If C gives turbidity immediately with Lucas reagent, है ना? With Lucas reagent is what? Lucas reagent is ZnCl2 and concentrated HCl. So it means it must be 3-degree alcohol, है ना? It must be 3-degree alcohol. So the organic compound A is. So how to check? So we have to hydrolyze the compound. So if we do hydrolysis, so we should be getting 3-degree alcohol. This is so clear. So it means if I'm going to break bond from here, so here we write H and here we write OH. So this is the 3-degree alcohol that we get. If I break the bond over here, so here we write OH carboxylic acid and here we write H, which is 1-degree alcohol. ठीक है? 1-degree alcohol. If we break the bond over here, so again we get 1-degree alcohol. Here we write H, here we write OH. If I'm going to break the bond over here, so here we write OH and here we write H, which is again 1-degree alcohol. So there is no need to solve anything. Just you have to break the bond, you have to do the hydrolysis, and the one which gives 3 degree alcohol, that is going to be the correct answer. Clear? So option 1 is going to be the correct answer. Now let's do next question. So we have neopentyl alcohol. What is neopentyl alcohol? CH3, 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 and this is CH2OH. Is heated with an acid. So if it is heated with an acid, H plus, and we have to do heating, so we get mixture of alkene A and B in the ratio of 85 is to 50. Yani 85 is the major product, 85 1 is the major product. This is going to be Sedzev 1, right? And 15 if the ratio is 15, right? So this is the minor product and this is going to be the Hoffman one. Okay. So what are these alkenes? So just do the mechanism. It attacks over here. So we get CH3, 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 now CH2, OH2 positive. Now we have to remove water. So loss of water means CH3, CH3, then CH3, then CH2 positive, right? So this is 1 degree carbocation. Now what we are going to do? CH3, CH3 and CH3, CH2 positive. So this is 1 degree carbocation. So let's do methyl shift. Let's do methyl shift. So when we do methyl shift, so we get 3 degree carbocation, CH3 positive, then CH2, CH3. Okay. So from here we have one type of hydrogen, this. So if I remove orange hydrogen, any orange hydrogen, so we get CH2 double bond C, CH3, CH2, CH3. And if I remove yellow hydrogen, on removing yellow hydrogen, on removing or on eliminating yellow hydrogen, we get CH3, CH3, double bond CH and CH3. So which is Sedzev 1? Obviously more alkylation. This is the Sedzev 1 and this is the Hoffman 1. Okay, that's it. So A is the Sedzev, this is A, and this is going to be B. So we have to find out the correct match. So let's do this. CH3, CH3, double bond CH, CH3. So A is this and B is this. Okay? Yeah, B is this. So option 2 is going to be the correct answer. Clear? Option 2 is going to be the correct answer. Now let's do next question, bache. The major product B in the following reaction is. So see, we have CH3, CH2, CH, CH3. Now CH2O, CH2, CH3. So we have HI, heat. Same ether reaction na bete, ether reaction. So oxygen lone pair attacks on this hydrogen and iodine leaves. So we get CH3, CH2, CH, CH3. Then we have CH2, OH positive and then CH2, CH3. Okay. Now I minus attacks on this carbon and electron of this one shifts over here. We have to do SN2 attack, बच्चे, है ना? We have to do SN2 attack. So CH3, CH2, CH, CH3, then we have CH2OH plus CH3, CH2I. Now H2SO4 and heat. So if I want to do H2SO4 and heat, so what to do over here? So we have this CH3, CH2, CH, CH3, then CH2OH, H2SO4 yani H plus and HSO4 minus. So what we are going to do? Oxygen attacks on this H plus and this leaves. So we get CH3, CH2, CH, CH3, then CH2OH2 positive, बच्चे. Yeah, OH2 positive. Now water leaves. So when water leaves, we get CH3, CH2, CH, CH3, and then this CH2 positive. So this is 1 degree carbocation. So we have to do hydride shift. So let's do hydride shift. So if we do hydride shift, we get CH3, CH2, C, CH3, and this CH3 positive. Now we have to form elimination reaction HSO4 minus. So it abstracts this yellow hydrogen to get SIDZF product. We have to remove yellow one to get SIDZF product. SIDZF product. Okay. So what is the answer? CH3 CH double bond C CH3. ठीक है बेटे. So this is going to be the correct answer. Now moving on to the next question. Which of the following derivatives of alcohol is unstable in an aqueous base? Aqueous base. So see, first is going to be the correct answer. How? See, we have OR and double bond and Me. ठीक है? ठीक है? So see, if we have base OH minus, so OH minus attacks over here and we get this. ठीक है? So we get Me double bond O and we get OH over here. Is it clear? Are you getting this point? The question says ki which of the following derivatives of alcohol is unstable in an aqueous base? It means from the alcohol we can form this thing, right? We can form this thing. The point is that ki suppose we have CH3 C double bond OH and on reaction with alcohol, what we are going to do? We are going to eliminate water na, and we are going to put CH3 C double bond OR. Is it clear? So this is going to be the derivative of carboxylic acid basically. कह सकते हैं, we can say this. So the point is that कि which is unstable in aqueous base. It means we can do hydrolysis or we can break bond, right? Bond breaking should be there in presence of base. So we have to apply this concept. In order to get the answer. That's it. Okay, otherwise OH minus cannot attack anywhere. Right? It cannot attack any other option. 2, 3, 4. Okay, bete. Now, let's do next question. The major product of the following reactions. Again dehydration question, right? Again dehydration question. First, OH is converted to OH2 positive, then water leaves, we have the carbocation formation, right? And now if you look for the option, heating is not given, but if you check options, so we have alkene in the product, so it means you have to do elimination, and when you do elimination you get option number 1 is as the correct answer. Okay, so just try it at home. Now let's do next question बच्चे. An organic compound A with empirical formula C6H6O gives sooty flame. So if it is C6H6O, so it means this is going to be aromatic, right? So sooty flame on burning. So sooty flame on burning means unsaturation is there. Unsaturation is present. Now question is, its reaction with bromine solution in low polarity solvent result in high yield of B, and B is. So we have one oxygen, na? So one oxygen hai, so we can have alcohol or ether. But we do not have any reaction of ether, right? We do not have any reaction of ether in the presence of bromine and CS2, okay, which includes 6 carbon. So what we are going to do? We are going to write phenol, and phenol on reaction with Br2 in the presence of CS2, we get para as the major product. Para bromophenol is the major product. So this is B. So option 1 is going to be the correct answer. Okay, that's it. Now moving on to the next question. Find out the major product from the following reaction. So we have this double bond O, alkene, and this. And we have CH3 MgBr. MeMgBr, it is CH3 MgBr. Okay, so If we only have CH3 MgBr, so what happened? Delta positive, delta negative. This is polar, so we write delta positive over here and oxygen delta negative. So CH3 attacks on this carbonyl carbon, electron of this bond shifts to oxygen, and oxygen forms bond with MgBr. So we have this situation. Matlab we will have this situation O. Here we write CH3 and here we write MgBr. ठीक है? If we have CH3 MgBr alone, but we have CH3 MgBr in presence of CuI. In presence of CuI. So what do we get here? With the reaction of that, we get R2Cu MgBr. ठीक है? R2Cu MgBr. So basically, what do we get from here? We will write this Cu, CH3, CH3, then MgBr, and here we write positive. ठीक है? So this reaction is similar to Corey-House synthesis. So what happened in that? We have Rx plus Li. So first we form RLi plus LiX. Then on reaction with CuX, we get R2CuLi. So this is we are going to do, right? So here in place of RLi, we have CH3 MgBr, right? So we are going to do this thing only. So we have this. Now what will happen? We have double bond, and here we have this. We have Cu positive. Here we write MgBr. Here we write CH3, and here we write CH3. Now what will happen? This methyl group attacks on this carbon. Electron of this bond shifts over here, and electron of this bond shifts to O minus. So we get this O minus. Here we write 2CH3. ठीक है? Okay, 2CH3. Now what we are going to do from here? So this is the difference. Now it becomes soft. It becomes soft nucleophile. So it attacks on soft position. Soft position. Right? It attacks on soft position. So next thing is we have propyl iodide. Propyl iodide means CH3CH2I. CH2I. So this is delta negative and this is delta positive. So what happens over here? Electron of this bond shifts over here and forms C double bond O. Then electron of this bond shifts to this carbon, and this carbon attacks on this CH2 and I leaves. So here we write CH2, CH2, CH3, and here CH3 and CH3. Okay. Now on the basis of that, which is the correct answer? Which is the correct answer? Option 1 is going to be the correct answer. Clear? So just try to understand. This is simply the reaction which is similar to Corey-House synthesis. Okay? So please learn this. It's just a different application of this one. Okay? Now, next question. We have LiBH4. So reagent based question. So this reagent is used to convert esters or cyclic esters which are lactones, okay, to alcohol. That's it. So this is the ester group. So we are going to write alcohol over here. So this is COH, and here we write CC and CH2OH. Okay. So CH2, CH2OH. So 2 is going to be the correct answer. That's it. Clear? No role of H2O positive and all. Okay? Nothing. So we have this situation. Okay, bete. The option 2 is going to be the correct answer. Now let's do this question. We have CH3, CH2, CH. Now H3PO4 है ना? H3PO4 it will do what? OH2 positive bete and then CH3. ठीक है? CH3. Now what happens? When water leaves, we get CH3, CH2, CH positive and CH3. Now NaI provides I minus. It attacks over here. So we get CH3, CH2, CHI, and here we write CH3. ठीक है? Okay. Now we have Mg dry ether. So we have CH3, CH2, CHI, and CH3. Now Mg dry ether. So we have to form Grignard reagent. So we write CH3, CH2, CH, MgI, and CH3. Now we have D2O. So D2O or H2O, right? So same thing. Now we are going to do hydrolysis. So just break this bond. So this is delta positive. So here we write OH. Delta negative. So here we write H. But here we have D2O. So here you write OD. And here you write T. So it means answer is going to be CH3, CH2, CHD, CH3 plus MgIOD. Okay, so answer is going to be third. That's it. Now let's do next question. ठीक है, we have this one. Mg, सबसे पहले Mg है. Dry ether is not given, but we have to form Grignard reagent. So we write MgBr. Okay. अब now what happens? We can do intramolecular attack. So this is delta positive, delta negative, and this is delta positive and delta negative. So if delta negative attacks over here, so we get 3-membered ring, right? We get 3-membered ring. So 3-membered ring, highly unstable, highly unstable. Now next step, check options, check options. So what we are going to do? It means like we have Wood's reaction and all. So intermediate is going to be this thing, na? ऐसे ही बनता है generally. So if we have this MgBr, now we have to take next molecule of this Br and then we do nucleophilic attack. So this is delta positive, this is delta negative. So it attacks over here. Electron of this bond shifts over here. So we write double bond O, this O minus, here methyl, then CH2, CH2, then CH, and this is Br. ठीक है? Next, water is there. So if water is there, so from water, if you add water, you get option number 1 as the correct answer. Option number 1 as the correct answer. Okay, bete. That's a simple question. The point is that here we have to check options in order to find out the correct answer. Intramolecular attack cannot happen. So we are going to take another molecule of the reactant in order to do the nucleophilic addition. And this is nothing, this is nucleophilic addition reaction. Okay, nucleophilic addition reaction. Now, moving on to the next question, we have this situation. Okay, HCl and KOH is there, right? HCl and KOH is there and we have to form B. So let me write over here only. So we have this situation, then again 6-membered ring, then we have 5-membered ring. Here we have OH, here CH2, CH2, NH2, CH2, CH2, NH2 bete. Then we have 5-membered ring. ठीक है? ठीक है ना? We have 5-membered ring. So we have HCl. So HCl, oxygen lone pair attacks on this H and Cl leaves, right? ठीक है बेटे. So what we are going to do? NH2 and here we have OH2 positive. Now remove water. So just remove water. So an elimination of water we get this. Here we have positive charge. CH2, CH2, NH2. Okay. Ab now what we are going to do? Let's expand the ring. So just break this bond and form new bond over here. So we will have positive charge over here. This is new positive charge. ठीक है? So by doing so, we get this. Here we have positive charge, ठीक है, and here we have CH2, CH2, NH2, ठीक है. अब now positive charge is there. Now next step, we have base, right? So base is going to abstract hydrogen, ठीक है. Base is going to abstract hydrogen. So the point is that if you see the option 4 is going to be the correct answer, ठीक है. That's it. So base, we have hydrogen. So here we have hydrogen. So OH minus abstract this hydrogen, electron of this bond shifts over here. ठीक है बेटे. That's it. ठीक है. So option D is going to be the correct answer. Now moving on to the next question. So we have CH3, C, CH3, CH3, C, CH3, CH3, now CHOH, CH, CH3 and CH3. So we have H plus and heat. It means we have to do elimination reaction. Elimination reaction and product is going to be alkene. Question says the total number of possible products formed by tertiary carbocation is. So H plus है तो first oxygen lone pair attacks on this H plus. So we get CH3, C, CH3, then CH3, CHOH2 positive, then CH, CH3 and CH3. Then what we are going to do? Just remove water. So on removal of water, we get CH3, C, CH3, CH3, CH positive, CH, CH3, CH3. Now this is 2-degree carbocation, but we have to form product from 3-degree carbocation. So we can form product 3-degree carbocation by 2 ways. Either we can do hydride shift, or what we can do methyl shift, right? So we have this CH3, C, CH3, CH3, CH positive, then we have CH, CH3, CH3. So if we do methyl shift, so we have new carbocation over here, CH3, CH, CH3, then CH, CH3 and CH3. Now if we do hydride shift, so we have new carbocation over here, CH3, CH3, then CH2, C positive, CH3, CH3, ठीक है. So from the first one we get 2 products. One hydrogen is going to be this orange one, and another hydrogen is going to be blue hydrogen. So if you remove orange hydrogen, so we get CH2 double bond C, CH3, CH, CH3 and then CH, CH3 and CH3. So here we have the chiral center. See, this is chiral center, है ना? And no cis trans, no cis and trans. Here hydrogen they are same, so no cis trans. So here we have chiral center, so we get 2 products over here, R plus S. ठीक है. Now if we remove blue hydrogen, so we get CH3, C, CH3, double bond CH, not double bond C, CH3, CH, CH3 and CH3. So no cis trans over here. So abhi right now we have 3 products in hand. ठीक है. Now just try to form from here. So if we remove orange hydrogen and we can also remove yellow hydrogen, ठीक है बेटे. So the point is, if we remove yellow hydrogen, so we get CH3 C CH3, okay, or either I can write CH3 2, okay, CH3 2 C CH3, and we write CH double bond C CH3 and CH3. Again no cis trans, and if I remove orange hydrogen, so we get CH3 C CH3 CH3 CH2 C CH3 and double bond CH2. So again no cis trans. So we get, finally we have 5 products in hand. One product is this, second product is this, and iska RNA so total 3. Then we have fourth product, and then we have 5 product. ठीक है? So question says total number of possible isomers formed by tertiary carbocation of A is that is equal to 5. ठीक है? Next question. We have H2O. So what happens? If we have H2O, so we have double bond O, na? So OH minus can attack over here and electron of this bond shifts over here. So by doing so, we can write double bond O, and here we write O minus OH double bond O, this. Now in the presence of H plus, what do we get? We get double bond O, OH and OH. Up now we can do the same thing with this one, we can do the same thing with this one, है ना? We can do the same thing with any C double bond O. ठीक है? Up the point is that which one is more stable? So if you look for option 1, that is going to be more stable. Why? Because we have 2 intramolecular hydrogen bonding. One is this, one is this. So here we have 2 intramolecular hydrogen bonding. ठीक है? Hydrogen bonding. We cannot have this, we cannot have this. We can have this, but here we have only 1 intramolecular hydrogen bonding. So it means which one is more stable? Which one is more stable? Option 1 is going to be the more stable. Clear? Now, let's do next question. Ethylene glycol. See bete. We have double bond O, and OC2H5. So ethylene glycol is CH2, OH and OH. This is actually a nucleophilic addition reaction. So what happens? This oxygen lone pair attacks over here and electron of this bond shifts over here, right? So this is going to be a nucleophilic addition reaction. But what is the trick? What is the trick? So if you see here we have plus R and here we have plus H. Okay, so this carbon is less nucleophilic, right? Less nucleophilic. So nucleophilic addition will be over here. So what is the trick? What is the trick? You have to remove oxygen and hydrogen and hydrogen. Okay, so just remove hydrogen. So when you remove hydrogen, na, over here, remove hydrogen, can you remove water, right? This is the trick. Just remove water. So we get O, CH2, O, this. Then double bond O, OC2H5. That's it. So this ethylene glycol is also used to protect keto group. Also used to protect keto group. ठीक है? So what is the answer? H plus का no role. H plus, what is the role of H plus generally? If we have double bond this and double bond OC2H5. So in the presence of H plus, this oxygen lone pair attacks over here now. So we get OH positive. So this carbon becomes more electrophilic basically. ठीक है? More electrophilic. So nucleophilic addition is faster. That is the role of H plus. Okay, now let's do next question. We have alkaline KMnO4 and H plus. So we have CH3, so it is converted to COH. OCH3 remains as it is. Nothing happens. So option 3 is going to be the correct answer. ठीक है बेटे. Now let's do next one. Main products formed during a reaction of 1-methoxynaphthalene. So this is naphthalene, 1-methoxy is OCH3 with HI. Ether reaction same है ना. Oxygen lone pair attacks on this, I leaves, and then I minus further attacks on CH3. So what do we get? We get OH plus CH3I. ठीक है जी. So option 2 is the correct answer. Okay. Now let's do next question. What is the final product A in the given reaction? Same. It's just what you need to do. You have to do Markovnikov generally. So first what happens? CH3, CHOH2 positive, right? Oxygen lone pair attacks on this H plus and Cl minus leaves. Cl leaves. So CH3, now water leaves. On removal of water, we have CH3. Here we have CH positive and here CH3. Now this is 2-degree carbocation. This is hydrogen. So we have to do hydride shift. So let's do hydride shift. So on doing hydride shift, we get CH3. Here we have positive, then CH2, CH3. ठीक है. We have Cl minus, so Cl minus attacks onto this carbon, which results in the formation of third product, number 3 product. Okay bete, that's it. Chaliye. Now moving on to the next question. So we have OCH3 and NO2. ठीक है. OCH3 and NO2. अब now HCl है. तो carbon is less electronegative na. So here what happens? This attacks on this H plus and Cl leaves. So we have positive charge over here, OCH3 and NO2. ठीक है बेटे. ठीक है. Then what happens? Cl minus attacks over here. Okay. So we get OH, OCH3, Cl and here we write NO2. ठीक है बेटे. तो अब we have NaI or dry acetone. Dry acetone. Which reaction is this? Finkelstein reaction, है ना? Finkelstein reaction. So by Finkelstein reaction, we can form iodo, right? Iodo derivative, or we can say iodine derivative. So अब now what we are going to write? So as per this, we get option number D as the correct answer. So we get this one, OCH3, iodine and NO2. So option 4 is going to be the correct answer. Clear? Now let's do next question. We have OH. Simple question, right? So A is going to be para bromophenol, that is A, and if we write B, that is Reimer-Tiemann. So B is going to be major one, ortho. Why? Due to the intramolecular hydrogen bonding, right? So we get ortho. B is going to be ortho and B is going to be ortho, and that is this. So it means option 1 is going to be the correct answer. Clear? So this is A, this is B. Simple question. Now let's do next question. So we have SOCl2. SOCl2, we have to do nucleophilic substitution, right? Nucleophilic substitution. So if we have ROH in the presence of SOCl2, we get RCl plus SO2 plus HCl. ठीक है. So where nucleophilic substitution is possible? Here nucleophilic attack cannot happen. ठीक है. So OH, OH, and we have CH2OH. So this is benzylic position. So here nucleophile can attack, ठीक है, and this is allylic position. So here also nucleophile can attack. So on the basis of that, what do we get as the answer? So we get option 2 as the correct answer. Just we have to do nucleophilic attack. Okay, now that's it. Now we are moving to the next type of questions, and in this type of questions we are going to discuss questions related to practical organic chemistry, and which is used to detect the we have some tests which are used to detect the functional groups, so we are going to do that part only. Okay, so the first question is bete, the organic compound that gives following qualitative analysis. So dilute HCl insoluble, it means it is not basic. So if it is not basic, so option 2 is incorrect, option 3 is incorrect, right? Next, NaOH soluble. So it means it is acidic. So if we have OH, so in presence of NaOH, what do we write? We write ONA, right? We write ONA. Clear? Now, then Br2 water decolorization. It means unsaturation is also present. Unsaturation is present, right? So we have only two options, 1 and 4th. In the 4th, no unsaturation, no unsaturation. So it means option 1 is going to be the correct answer. Clear? That's it. Now moving on to the next question. Consider the following reaction. We have this, and in the presence of chromic anhydride, it gives P. The product P gives positive steric ammonium nitrate test. So steric ammonium nitrate test is for alcohol. If we have alcohol group, OH group, then we get red color, right, with steric ammonium nitrate test. So the point is, question says this is because of the presence of which of these OH group. So see, this is 2 degree alcohol, this is 3 degree, this is 1 degree, and this is also 2 degree alcohol. So chromic anhydride में 1 degree alcohol, 1 degree alcohol, 2 degree alcohol, allylic alcohol, right? Allylic alcohol can oxidize. So 1 degree alcohol gives aldehyde, 2 degree alcohol gives ketone, and if we have allylic, so allylic also gives aldehyde. ठीक है, 3 degree alcohol does not oxidize. So if 3 degree alcohol does not oxidize, so 3 degree alcohol is free over here. So this is responsible for giving the positive steric ammonium nitrate test. So option 1 is going to be the answer, only second. Clear? That's it. There is no need to write everything. Now moving on to this question, we have organic compound A, which is C9H10O. When treated with concentrated HI, yields compound B and C. So it means this is ether. So ether है, तो we can get one alcohol and one halide. ठीक है, we get one alcohol and halide. ठीक है. Now B gives yellow precipitate with AgNO3. So it means B must be halide, right? Yellow precipitate with AgNO3. Fine. Halide may be iodide because AgI color is yellow. Whereas C tautomerized to D. It means we have alcohol, but here we get enol, right? Enol form होगा, which is tautomerized to D. यानी tautomerized to keto form, which gives positive iodoform test. Right? Positive iodoform test means we should be having this group na, or CH3 CHOH group. ठीक है? So let's see the option. ठीक है बेटे। अब हेलाइड है, हेलाइड होगा, राइट? So the point is that if we see option 3, so here what happens? We get OH positive, ठीक है? Now I minus can attack over here and this leaves because this is benzylic position. Okay, so we get CH2I plus CH2 double bond CHOH, which is tautomerized to keto form, right bete? And which is positive iodoform test. So option 3 is the correct answer. This is the only possible thing, right? This is only possible thing because I minus can be removed. When I minus can be removed, so we have benzylic carbocation. So we get AgI ka precipitate. Clear? So in that way we have to think. So option 3 is going to be the correct answer. Now let's do next question. We have two compounds A and B with the molecular formula C3H6O undergo Grignard reaction with methyl magnesium bromide to give product C and D. तो product C and D, seric ammonium nitrate test C and D positive, यानी OH is present, OH is present. Lucas reagent, turbidity obtained after 5 minutes. So Lucas reagent gives turbidity with 3 degree alcohol immediately. So this is 3 degree alcohol, and with 2 degree alcohol it gives turbidity after 5 minutes. Iodoform test positive, it means we should be having this group or we should be having CHOH this group. And in D, there is no need for that. So just we have to look these things from the options. So see, if you see this one, so we have CH3CHOH. Iodoform दे सकता है ना? It can give iodoform, and this is 2 degree alcohol. And this is 3 degree alcohol. So from this, option 1 is going to be the correct answer. Because see, this is 1 degree alcohol, नहीं होगा. This is again 1 degree alcohol, नहीं. ठीक है? तो this is 3 degree alcohol and D is 2 degree alcohol, no. D should be 3 degree alcohol while C should be 2 degree alcohol. So option 1 is going to be the correct answer. Now moving on to the next question. Seric ammonium nitrate test, that is used for alcohol detection, right? CHCl3 alcoholic KOH. If we have amine, 1 degree amine, so in the presence of CHCl3 alcoholic KOH, this is called carbyl amine reaction. Carbyl amine reaction. So we get false smelling compound. False smelling compound. ठीक है? So this is used to detect 1 degree amine. So we have amine. So option 1 is going to be the correct answer. Clear? Now moving on to the next question. Which of the following compounds gives pink color on reaction with phthalic anhydride in concentrated H2SO4 followed by treatment with NaOH? So beta, phthalic anhydride is this. Okay, this is phthalic anhydride. Now it gives pink color. So if we have phenol, na, something phenol or derivative of phenol. So here we have H and here we have H. So what we are going to do, just remove water. ठीक है? Just remove water. So when you remove water, na, so you get this. O double bond O. Here we write OH and this is going to be OH. So this is phenolphthalein, right? This is phenolphthalein, and phenolphthalein gives pink color na with NaOH. Phenolphthalein gives pink color. So the point is that para position of phenolic group should be free. So we have to check this thing. So this is OH, but para position is not free. This is OH, para position is free. Para position is free. So it means this is going to be the correct answer. Para position should be free, right? This is the trick. This is the key point. Here para position is not free. Para position is occupied, right? So we cannot form phenolphthalein. So option 2 is going to be the correct answer. Clear? Now let's do next question. Reaction of Grignard reagent C2H5 MgBr with C8H8O followed by hydrolysis gives compound A, which reacts instantly with Lucas reagent. It means this A is going to be 3-degree alcohol, and if it is 3-degree alcohol, we get 3-degree alkyl chloride to give compound B. So it means we have to find out which one is 3-degree. This is 1-degree. This is also 1-degree. देखें, this is 3-degree and this is 2-degree. So which one is the answer? Option 3 is going to be the answer. There is no need to check any other thing. You have to check in that way. Okay. Okay. Let's do next question. Compound X when treated with phthalic anhydride in the presence of this. Same question, right? So we are going to get phenolphthalein. So for phenolphthalein, we need OH. OH ko we can also say carboxylic acid. And if we have this phenolic group, and if it reacts with phthalic anhydride, ठीक है? So just remove water and we get phenolphthalein. We get phenolphthalein. ठीक है बेटे? So fourth is going to be the correct answer. Now next. ठीक है? Consider the following reaction. We have Ag2O and heat. So what we are going to do over here? Ag2O and heat. So see, heat hai, we get precipitate. So if you look the options, we have alkynes and alkenes. We have alkynes and alkenes. So terminal alkynes are acidic. So we have option 1 and option 2. Okay, terminal alkynes are acidic. So if we take option 3, so we get CH3C triple bond C minus, and here we write Ag plus, which gives precipitate. On reaction with, if we have this CH3C triple bond CH on reaction with Ag2O and heat. ठीक है? Fine. Then we have Hg2 plus H plus. So simply hydration of alkynes, which is the Kucherov reaction. Kucherov reaction. So what happens in that? We have to do Marconic of addition. So double bond CH. ठीक है बेटे? Double bond CH. ठीक है? CH2 हो जाएगा बेसिकली. C माइनस है ना, हाँ CH है ना, तो CH2 हो जाएगा. अच्छा एक मिनट, लेट मी राइट. I should not write from here. I should be writing from here. If it is CH3C triple bond CH on reaction with Hg2 plus H plus, so we have to do, this is Kucherov reaction and we have to do Marconic. ठीक है? So CH3COH double bond CH2. Now this is the enol form, so this is tautomerized to keto form. ठीक है? Then in the presence of NaBH4, we get 2-degree alcohol. So 2-degree alcohol. We get 2-degree alcohol, which gives turbidity with Lucas reagent. Turbidity after 5 minutes. ठीक है? Due to formation of this one. ठीक है बेटे? अब now, if we have option 1, because terminal alkyne should be there. So option 1 में we can write C minus Ag. ठीक है, fine. Then if we take CH triple bond CH, so in the presence of Hg2 plus H plus, we write CHOH double bond CH2, which is tautomerized to CH3 C double bond OH aldehyde, which on reduction NaBH4 gives CH3 CH2 OH 1-degree alcohol. So 1-degree alcohol will not give turbidity. ठीक है? Does not give turbidity at room temperature. होता ही नहीं है. So this is not correct. Option 3 is going to be the correct answer. ठीक है? Now we are moving to the last type of question. That is a question based upon the use, and if you don't know this thing na, so matlab, you can find out the answer. How? Let me tell you. See, question is butylated hydroxyanisole, which is BHA, and we have butylated hydroxytoluene. ठीक है? Butylated hydroxyanisole and butylated hydroxytoluene, they are very good antioxidants, right? They are very good antioxidants. So question says butylated hydroxyanisole when added to butter increases its shelf life. Yes, it's true. Butylated hydroxyanisole is more reactive towards oxygen than food. Yes, that is the role of antioxidants. So both A and R are correct, and R is the correct explanation of A. ठीक है? R is the correct explanation of A. Okay, beta. That's it. So that is basically some memory base. You should know कि by BHA, BHT, they are going to be the antioxidant. That's it. We have completed questions of alcohols, phenols, and ethers. I hope you get enough knowledge related to this. If you like this video, then you can hit the like button. You can write down in comment section if you need any other help. Right? In the next video, I'm going to take some questions related to aldehydes and ketones. And after that, I'm going to take some questions related to carboxylic acid. Till then, bye. Take care.